then subtract the old objective function with the adding of these two variables. So I have z, then plus. So because this is a minus, so this is gonna be minus 4x1 minus 4x2. So this is gonna be plus s1 plus s2, a minus a0, a2 minus a2 0, and this is gonna be minus 90. So this is my new objective function. So then I will start up my tableau. So this is my phase 1, iteration 1. So the same thing we have done with the big M method and the simplex. So we have here the variable, we have z, then we have x1, x2, s1, s2, and a1, a2 with the right hand side. We have the optimality condition. And then I should have the constraint with the like basic solution. So when I have artificial variable, they're gonna having the solution. So a1 and a2 right now, they are the basic solution. So a1 0, the same coefficient for my first constraint, 1/2, 3 minus 1 0 1 0, and this is gonna be 50. And here 2.5, 1 0 minus 1 0 and 1, and this is gonna be 40. So we have here minus 4 minus 4, 1 1 0 0 minus 90. So even if it's originally was a minimization problem, it's right now a maximization. So I should look to the like largest negative number, but both of these two numbers are the same, so I can start up either way. So like there is nothing like heading me over here, so like I can start as this one as the pivot column or this one. So it's more convenient for me if I look up here. It's way easier for me to do the calculation. So if you have a Torah, for example, it will ask you which column you would like to prefer to do it. But like simplex will be do it automatically. So then I gonna calculate the ratio. So I gonna decide which of these gonna be my bottleneck. So 50 over 3, which is equal 16 by 2 over 3. Then 40 by 1, which is equal to 40. So this is one is my pivot column. So my pivot row, pivot row will be x2, so I'm gonna replace a1 by x2 and divided the whole thing with 3. Then I should get rid of 4 and get rid of 1. So I'm gonna nullify them using this row. So after dividing a1 by 3 to make it x2, so it's gonna be changed into 0, half 1 minus 1 over 3, 0, 1 over 3, 0, equal to 16 by 3, 2 over 3. So I don't need to have, by the way, the calculation for A1. But let's like put it here to see what's happening, but I don't need the whole column. Okay. So then we're gonna change A2. So this guy over here, this one should be 0. So that's very easy. So I don't need to multiply. So we have here the alt A2. So I put it as it is. So it's basically 0, 2.5, 1, 0, minus 1, 0, 1, which is equal to 40. And just put the pivot row as it is. Because like I want to get rid of 1 and I don't need to multiply it by any number so far. So 0, half, 1, minus 1 over 3, 0, 1 over 3, 0, which is equal to 16, 2 over 3. So this is my new A2, which is 0. So this is 2, this is 0, 1 over 3, and half minus 1 over 3, 1 is equal to 23, and 1 over 3. Then I gonna change this minus 4, so I gonna multiply this guy after dividing it by 3 by 4 and then add them together. So here my alt z, so I put it as it is, so it's a 1 minus 4 minus 4, 1, 1, 0, 0, minus 90. Then we have the pivot row, multiplied by 4. So I can put it like here, or what it was originally, to not get confused. So 0, half, minus 1 over 3, 0, 1 over 3, 0, which is equal to 16, 2 over 3. So I multiply whole thing by 4, so 0 by 4 is 0. This is gonna be 2. Sorry, I have missed this one. So half 1. I will rewrite it again. So this is the original pivot row. So 0, half, 1, minus 1 over 3, 0, 1 over 3, 0, which is equal to 16, and 2 over 3. So 0 by 4 is 0, half by 4 is 2, 1 by 4 is 4, 1 over 3 by 4 equal minus 4 over 3, 0, 4 over 3, 0. Finally, it's gonna be 66, 2 over 3. Then we add them together. So we have here 1. So this is the new z. Minus 2, 0, minus 4 over 3, 1, 4 over finally minus 23 and 3. So since we have calculated the new A2 and the new Z, we can add them to my tableau. So here my tableau. So here I have my variables. I have Z, x1, x2, s1, s2, and a1, a2, right hand side. Then we have the optimality. So we have here x2 and we have a2. So x2 was 0 and half, 1 minus 1 over 3, 0, 1 over 3, 0, and 16, 2 over 3. So in the homework or in the exam you don't need to put the A1 column, but regardless we will keep it. So here we have the new one, 0, 2, 0, 1 over 3, minus 1, minus 1 over 3, 1, 23, and 1 over 3. We have Z here is 1, minus 2, 0, minus 1 over 3, 1, 4 over 3, 0, minus 23 and a half. Since it's a maximization or even like converted from minimization, we didn't reach out our optimality condition yet. So we're gonna choose the highest negative value. I have two of them, this guy and this guy. So this is the highest negative value. So this will be my pivot column. Then I'm gonna determine the ratio by dividing the right hand side by the coefficient. So this will be 16 and 2 over 3 by a half, so it's multiplied by 2, 33 and 1 of a third, and this is gonna be divided by 3. For sure this is gonna be less, so this is 11, 2 over 3. So I was fortunate over here to replace the artificial variable, but you don't force it. So like let's say this ratio was less than this one, so you're gonna do it again. So you're gonna replace x1 by x2. So you cannot force to leave the artificial variable in the first place. So the intersection between them is my pivot element. Then I'm gonna divide the pivot row by element. So this is gonna be 0, 1, 0, 1 over 6, minus half, minus 1 over 6, half. This and also this one will be 11, 2 over 3. I will rewrite it again in the top. So this is my new pivot row, which is gonna represent the x1 variable. Now let's memorize it again. So it's 0, 1, 1 over 6, minus half, minus 1 over 6 and half and equals 11, 2 over 3. So then I need to change some values. So I want to change x2 and also z. So I have the old x2, which I pick up the original one. So I will put this one, the original values. So it's start up with 0, half, 1, minus 1 over 3, 0, 1 over 3, 0, which is equal to 16, and 2 over 3. Then I have the pivot column, or sorry, pivot row. Then I gonna multiply this one by half. So we have here 0, half, sorry, so then we have 0 over here. Yeah, you need to be very accurate in this kind of solution. So like, and thankfully we do it via MATLAB, so, or simplex. So and we will cover this in a couple of coming lectures. So we have here half, 0, 1 over 12, minus 1 over 4, minus 1 over 12, 1 over 4. We have then 5.8333. Then we have the calculations for it. So we have the new x2. So 0 by 0 is 0, half and half 0, 1, 1 over 3 by 1 over half, so it's 0.4166, and this is gonna be positive. This will be 0.4166. Okay, so this is 1 over 4, finally 10.83. Then we're gonna go back to z. So we want to nullify this value through this one, so we can add them together directly, or you just put the pivot row, so to make your solution more consistent. So we have the original pivot row, which is 0, 1, 0, 1 over 6, 1 and a half, minus 1 over 6, half, which is equal to 11, 2 over 3. Then we put old z, so this is our old z here. So 1 minus 2, 0, minus 1 over 3, 1, 4 over 3, 0, which is equal to minus 23, and third we have the pivot row. Then you're gonna multiply it by 2, so 0 by 2 is 0, then 2, then 0. Then we have here 1 over 3. Then this is gonna be okay. So I think I have missed some numbers over here. So 0, 1, 0, minus 1. It should be 8 variables. 1, 2, 3, 4, 5, 6, 7, 8. So it's correct. So 0, 2, 0, 1 of the third. Yes, minus half, minus 1 over 3, 1, which is equal to 22, and 2, 23, and third. So we can add these two rows together. So 1 plus 0 is equal to 0, minus 2 plus 2 is equal to 0, 0 plus 0, 0, minus 1 to the third plus 1 to the third, 0, 1 and minus 1, 0. This one will be 1, 1, and 0. So since we have the all rows and the optimality condition, we can create the tableau. So this is the tableau. So you don't need to add the artificial, but even though I will put them into the calculation. So we have the variable which are z. We have x1, x2, s1, s2, and a1, a2 with the right hand side. We have the optimality condition. Then, so the basic solution for this iteration was x2 with 0, 0, 1 minus 0.416, 1 over 4, 0.416, and minus 1 over 4 with 10.833. And x1 is the another basic solution with 0, 1, 0, 1 over 6, half, minus 1 over 6, and half, with 11 and 2 over 3, with optimality condition of 1, 0, 0, 0, 0, 1, 1, 0. So since all my decision variables are more or equal to 0, so I have reached out the optimal solution for phase 1. So I can switch right now to the second phase. So phase 1 is ended, and I can start up my phase 2. So to start the second phase over here, so we need to add the contribution of my z function. So remember, we start up with minimization problem and then we switch it back to maximization. So my maximization is z equal to minus 25 x1 minus 35 x2. So then I will start my second phase to calculate the cost of the production equation. So cost of production, but I have already made some decisions here. So like x1 and x2 is already have been contributing so far, and because of these values I don't have any contribution for the artificial, so I can get the advantage of this one. But I cannot put the same amount of z because I already have exhausted the resources to make these things. So the only way to have the cost of the reduction equation is to subtract the values from here to nullify them and see what's happening for it. Okay, so the only way I can do it via this new constraint. So these actually are constraints. So if I want to write up this in equation, so this is gonna be 0z plus x1 minus 0.416, sorry, plus x2 plus, let's rewrite it again from the beginning. So this is gonna be 0z plus 0x1 plus 1x1 minus x1, sorry, x2 minus 0.416 s1 plus 1 over 4 s2, which is equal to 10.8. And this I can rewrite it in this form. So 0z plus x1 plus 0x2 plus 1 over 6 s1 minus half s2, which is equal to 11 2 over 3. So my z equation becoming as follow: z, so I should have the decision variable in the left hand side and the quantity in the right hand side. So this is gonna be plus 25 x1 plus 35 x2, and I shouldn't have these values, so I put my equations which I gather from the first phase over here. So I put this equation, call it equation 1, and I should put this equation equation 2. Then I will multiply x2 by the contribution of x2 and x1 by the contribution. So this is gonna be multiplied by 35, and this one will be multiplied by 25. So 0z plus 0x1 plus x2 minus 0.416 s1 plus 1 over 4 s2, which is equal to 10.83, all together multiplied by 35. And also I have the other equation, 0z plus 1x1 plus 0x2 plus 1 over 6 s1 minus half of s2 equals 11.67 multiplied by 25. So here we have z plus 25 x1 plus 35 x2 minus 0z plus 0x1 plus 35 x2 minus 14.85 s1 plus 8.75 s2 is equal 379.16. We have the other equation minus 0z plus 25x1 plus 0x2 plus 4.16 s1 minus 12.5 s2, which is equal to 291.66. So we can subtract this equation. We have z plus 0x1 plus 0x2 plus 10.416 s1 plus 3.75 s2. Why? Because this is a 0, so minus minus is positive, and this is a minus minus, so this is becoming plus 14, and this is a plus, so plus minus is negative, so this is gonna be 10, and this is gonna be minus minus, so this is a 12 will be positive, and this is will be minus immediately negative, so I subtract each other and take the positive value equals 670.83. So we have here the z equation. So z plus 0x1 plus 0x2 plus 10.416 as plus 3.75 as 2, which is equal 670. Now the other equation, I will just take them immediately from the first phase. So I just copy paste this equation over here, like from here. The tableau from here is the same one. So I don't need to have any change in these other two variables. So when I start up my tableau, I just will change my optimality condition. So we have here the variables. We have z, then the optimality if we reach it. And then we have the right hand side, x1, x2, s1, s2. So we have here x2 and x1, we just copy them from the first phase. So this is phase 2, first iteration. Be 0, 1, 0, 1, minus 0.416, 1 over 4, 10.83, and this is going to be 0, 1, 0, 1 over 6, minus half, 11, and 2 over 3. I'm going to rewrite this y, 1, 0, 0, 10.416, 3.75, 670.83. So since all of these variables in the optimality row are more or equal to 0, so my solution is optimal. So I have reached the optimal condition. So z, so originally it was minimization, so right now it's minimization. Okay, with x1 is equal to 11, 2 and 3, x2 is equal to 10.83. So since these values doesn't have any slack, so the binding constraint are C1, C2, and non-basic solution are S1 and S2. Okay, try to solve the same problem using Big M method and see which one is the easier. Okay.